Okay, so what we're talking about today is geometric sequences. And if it's a geometric sequence, then we're basically going to be multiplying the same to each term. Okay? Now, be nice to Mr. Moody, you guys, as you're copying and taking notes. If you're crazy and rowdy, he has the authority to send you to the office. And you can sit in the office until I get back, all right? Really. Okay, so here's how it works. We know that you can make any particular sequence because it's a list of numbers in order, okay? So what we're doing this time is we're multiplying. So let's consider this, okay? G1 is 4, and then G of n, which means we're going to make the next term. G of n minus 1 is the previous term. So we're going to take the previous term, which is 4, and we're multiply times 5. Okay, that's what we're going to do. So if we want to go ahead and make the first 4 terms, the first term is 4, right? Then the second term, term 2, goes into the formula. Okay, 2 minus 1 really means G1. We know G1 was 4, so 4 times 5 is 20. Okay, now 20 is term 2. So to make G3, third term, it's going to be take the previous term, which is the 20, multiply times 5. So really in words, what we're really doing is taking each term, each previous term, we're going to multiply by 4. So 4 times 5 is 20. 20 times 5 is 100. 100 times 5 is 500. And it just keeps going, it keeps going, it keeps going. Okay? So there's our first, second, third, and fourth term, because it says to make a term, take the previous term that you just wrote down, multiply times 5. Okay? Hopefully that makes some sense. All right? This is, of course, in recursive form. Recursive form. Okay? Right there. So, the sum of the terms of a geometric series is called a geometric series. Okay? So to have a geometric series, that's where you add them. Okay? So you're going to take and add. So for instance, if I want a geometric series is different. Series is to add all terms. Okay, that's the difference between a series and a sequence. So in this case, if I wanted to add the first 4 terms, I would go 4 plus 20 plus 100 plus 500. Let's see, that's 624 if you add them all up. So you'd have an actual answer to a series, okay, because you add them all up. If it's a series, we're going to add them all up. And we can actually add series to arithmetic ones as well. Okay, so let's take a look at what we have. So, for example, consider the geometric series 3, 12, 48, 192. Okay, so to find the series, because series means to add them all up, sequence means to list them. Okay, series means to add them all up. I'm just going to go 3 plus 12 plus 48 plus 192 is 255. So that's the difference between a series and a sequence. A sequence is just to list the numbers, and a series then is just to give us the answer to the sum or to add them all up. Okay? All right, here we go. Before starting their next concert, Stellar Attraction Sales releases a second CD during the first week. 500 copies are sold. The band's manager predicts that it will double each week the band is on tour. Okay? So if it doubles, we go 500, 1,000, 2,000. So if it's going to double, then obviously the next one's going to be 4,000, right? So forth and so on, right? So what I'd like you to do right now is to take a minute and complete the chart all the way down to 12, including the sum. So we're going to add on this one. I want you to know what we're doing, okay? That's 4,000 because I doubled. I'm just adding them up. So if I take and add 500 plus 1,500, so I'm adding 500 plus 1,000. Watch. 500 plus 1,000 is 1,500. Okay. Then I take my 1,500 and add it to 2,000. Okay, because I'm just adding these numbers. Gives me that. And so if I take my 3,500 and add it, I'm adding these numbers. Okay. So I want the total. So if I were to write it out as 500 plus 1,000 plus 2,000, okay, I'm going to get 3,500. Then I'm going to add another 4,000, right? If I add a 4,000, then I get a 7,500. Okay, so I want you to complete the chart all the way to the 12th term. Okay. Okay. So go ahead and complete the chart all the way down to the 12th. Okay. So if I just do this to the 12th term, alright, I've got my 4,000, next one would be an 8,000. If I take 7,500, so I'm going to take 7,500 and add that to 8,000. I get a 15,500. Okay, then if I double that, I get 16,000. If I add that to 15,000 plus 16,000, an answer of 31,500. Okay, then if I double that, I get 32,000. Let's see, that would be my 5th, 6th, 7th. Okay, take that and add that to 32,000. Up to 63,500. Add that. Hopefully you guys are ahead of me. 64,000. Add that to my 63,500, and I get 127,500. Double that. 128,000. So if I add 128,000 to my 127,000 plus my 127,500, I get a 1 million. Is that right? Yeah, 1,400,000. That's right. Is that right? That plus that can't be right. Hold on. I don't think my calculator's good. Oh, I put too many zeros. 128. 1, 2, 3 plus 127,500. Okay, there we go. 255,000. 255,500. Okay, that's the 9th term. 10th term, double that. Let's see, that would be 24, 25, 6, 25. 6, 1, 2, 3, 256,000. If I add that to my 255,000, right? So I'm adding that to my. So if I add my 256,000 to that, I get a 51,000. No, 511,500. Double that, and double that. And I'll let you guys go ahead and finish that, okay? So, if we need a recursive formula, okay, hopefully you guys have this.
Are we good for tomorrow?
We're good for tomorrow. I sent you an email, okay? Okay, yeah, I'm sorry I'm recording for tomorrow. Yeah, that's okay. So recursive formula, let's check it out. So to do a recursive formula, we know for sure we have to do the first term. So the first term is 500, right? And then if we want to make the formula, this series, this recursive formula for the series, not for the sequence, I'm going to go a of n equals, well, let's see, a of to the n minus 1. What am I doing each time? I'm doubling it, aren't I? I'm doubling it, so I'm just going to go multiply by 2, okay? There's my recursive formula, okay? Turn the page. Okay, so consider the pattern of dots shown in the diagram, okay? Draw the next pattern, so I can do that. Alright, looks like I've got 1, 2, 4, and then 8. So it looks like I'm doubling. So, okay, 1, 2, 3, 4, 5, 6, 7, 8. And then I'd go 9, 10, 11, 12, 13, 14, 15. Let's see, it should be 16, right? If I'm double, I've got 1, 2, 4, 6, 8, 2, 4, 6, 8, 10, 12, 14, 16. Whoops, forget this one. I got to get carried away, okay? Represent this pattern as a sequence, okay? So as a sequence, let's go ahead and write 1. So we got T1 is 1, T2 is 2, T3 is 4, T4 is 8. Okay, so there it is. Represent this pattern as a sequence, or I can write it as 1, comma, 2, 4, 8, and then of course I'm going to go dot, 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 because there's more to come, right? Is this geometric? Yes, because we're multiplying. So yes, it is geometric because we are multiplying by 2. So we multiply by 2. So yes, multiply by 2 each term, right? So a recursive formula, let's do that over here, okay? So if we do a recursive formula, I'm going to start out with A1. A1 is equal to my first term, which is 1. Okay? Then A to the n is to make the next term. So A to the n minus 1 is the previous term, and I'm multiplying by 2, so times 2. Okay? Now to graph this, okay? So let's graph this. Okay, to graph this, let's see how this looks. Okay, so I'm just going to graph it on just a regular piece of paper. Looks like it gets pretty big. So I'm going to go, let's see, maybe 5, 10, 15, 20, 25. So if I graph paper, it'll look a lot better, but this will work. Okay, so I'm going to graph. Let's graph this sequence here. So I've got term 1, term 2, term 3, term 4, and I can even go to term 5, because I think term 5 would work. Okay, so the first term has a value of 1, so I'll put a dot here at about 1. Second term has a dot at a value of 2, okay, so maybe right about there. Third term, 4, right about there, okay. Doesn't look like much yet. Pretty soon it's going to start getting bigger. Term 4 has a value of, oops, hold on, term 1, 2, term 3, term 4 has a value of 8. If I went to term 5 would be 16. And what I notice now is it's starting to curve. Okay? I know that if it was straight, we'd call it arithmetic. As it curves, though, this one's definitely geometric. Okay? Alright, there it is. So, any questions? Hopefully none, because I'm not here. So what I want you to do is I've got a homework assignment for you guys, and then after the homework assignment, I want you to work on that. Then after the homework assignment, I want you to make an ornament for the room or for the tree. So to make the ornament, here's your rules. Here's what I want. I want it colored and made look beautiful. Okay, put some nice design, and I also want you to find the total area. Okay, and that's in centimeters. Centimeters squared, so I'd measure that. It's about, that looks like about 9. That's about 9 centimeters. Okay, if it's a triangle, I know the area is 1/2 base times height. So then the height of this triangle, let's see if I measure, it's about 7.5. So the area of one triangle is 1/2 times the base, which is 9, times the height, which is 7.5. Okay, and that'll give you the area of one triangle. Get that answer. But then there's a total of 4 of them. So we're going to take this answer, multiply that times 4, because there's 1, 2, 3, 4. So do all the work. Make sure the work gets on. Make sure your work is on this. So you put your work, your 1/2, 9 times 7.5. You get your one triangle. Then you multiply that by 4. Put your error. Make sure you put your name on there. So you might put your name on there. Okay, and then I want you to color it. Make it look beautiful, right? Color it. Make it look beautiful. Okay. And if you color it, make it look beautiful. If you put little designs on it, if you like to say pretty creative, then I'll give you an A. If you put little designs on it, make it look beautiful. If you don't put any designs on it and just put it together, I'll give you a 4. Your name and the work has to be on it. Then you cut it out, glue it together, and turn it in tomorrow. Okay, that's all I have for today. Okay.